Welcome to the deep dive. Today we're heading into, well, a really dramatic landscape. Machtesh Ramon in Israel's Negev desert.
That's right. You shared some fantastic material, location recordings and such.
Yeah, from the observation point, Route 40. And our goal is really to unpack its secrets, how it formed the life there.
Absolutely. The recordings give us a great starting point. Geography, geology, even wildlife and fossils. It's all in there.
So get ready for quite a journey. We're talking millions of years, massive geological forces. It's about how this incredible place came to be.
And what makes it unique today? From ancient oceans?
Yeah.
Yeah, all the way to modern ibex.
Okay, let's dive in. First off, where exactly is Machtesh Ramon? Let's orient ourselves.
It's located in the central Negev desert in Israel. It's pretty close to the Araba Valley and right next to the small town of Machtesh Ramon.
It's not your typical crater, is it? I mean, the scale is immense, world's largest.
Exactly. It holds the title for the largest erosional crater that's Machtesh in Hebrew on Earth.
Erosional, so not volcanic, not meteorite impact.
Correct. That's a crucial distinction. This was formed by erosion, by the wearing away of rock over a very long time, not a sudden event.
So carved out, essentially.
Precisely. And it's interesting, Israel actually has 3 of these large erosional craters. There's a smaller one near Dimona, another near Yerushalayim.
Right.
But Ramon is, well, it's the giant. It dwarfs the others.
Okay. And the recordings mention some landmarks you can see from the observation point. What paints the picture?
Yeah, from up there you get a great view. You can see the Bereshit Hotel, quite striking on the rim. There's also a camp lodge nearby.
Mm-hmm.
And the town itself, Machtesh Ramon, small place, maybe 6,000 residents, plus the visitor center. The Ramon Visitor Center is right there, too.
It also sounded like there's some adventure tourism. Rappelling.
Oh, yeah, definitely. You'll see blue signs marking a designated rappelling site. It's quite popular.
Do you just show up?
Well, usually you'd go with a local company. You typically need your own gear, and critically, you have to follow the nature park rules. Rappelling's only allowed at those specific spots.
For safety and preservation. Makes sense.
Exactly.
All right, location set. Now, the really fascinating part, how did this colossal thing actually form? The recordings hinted it was a very specific sequence of events.
It really was. And the conditions needed, that exact combination, it's quite rare. You find it mainly in Israel and parts of the Sinai Peninsula. It's like a geological story told in layers.
Okay, let's peel back those layers. Layer 1, sandstone. Take us way back.
Right. So picture the world maybe 200, 300 million years ago, totally different geography. There's a huge ancient ocean, the Tethys Ocean, west and north of here.
Okay.
And massive rivers, think Amazon or Nile scale today, were flowing from the east, from modern-day Arabia, Iraq, Iran. They carried enormous amounts of eroded material, mostly sand.
Pouring into this Tethys Ocean.
Exactly, depositing layer after layer of sand over millions of years that created this really thick sandstone foundation. That's layer 1.
Got it. Ancient rivers, sandstone base.
Right.
What came next? The recordings mentioned limestone on top.
Right. So, after the sandstone was laid down, the sea levels of the Tethys Ocean rose. The environment changed.
Deeper water.
Deeper water, different conditions. So instead of sand, you start getting deposition of other sedimentary rocks, specifically limestone and chalk. These form from marine organisms, shells, and skeletons accumulating.
Okay, so ocean life forms the next layer.
Precisely. You can actually see this difference if you drive down Route 40 into the crater. The upper parts are this lighter colored, harder limestone and chalk, and then below that, the cliffs are the darker, often more colorful sandstone.
Visible layers. So sandstone, then limestone, chalk. What's the next big geological chapter?
Tectonics. Mountain building. Around 70 to 80 million years ago, there was major plate movement. The Earth's crust shifted, buckled, and these flat layers of rock were pushed upwards, folded, and formed a whole mountain range.
So what was under the sea became mountains.
Essentially, yes. The analogy used sometimes is like a row of baguettes rising up from the dough, long parallel ridges with valleys in between. Mount Ramon itself was one of those ridges, one of those baguettes.
Okay, I like that analogy. Baguette mountains. What happened after they formed?
This is where the Dead Sea Arava transform the Rift Valley becomes absolutely critical.
Ah, the Rift Valley connection.
Yes. This huge fault line opened up, creating a really deep valley running north-south. It basically split the Jordanian mountains on the east from the Negev mountains, including Mount Ramon, on the west.
And that created a height difference.
A massive height difference. You've got Mount Ramon peaking at around 1,000 meters above sea level, and the floor of the Arava Valley plunging down to about 400 meters below sea level.
Wow, it's a nearly 1,400-meter drop over a relatively short distance.
Exactly, and that incredible slope, that steep gradient, is key to the next step. Intense erosion.
Okay, how did the slope lead to the crater?
So you have this mountain made of sandstone capped with harder limestone. That limestone cap initially protected the softer sandstone underneath,
Right.
but the immense pressure from the uplift and folding eventually caused the limestone cap to crack. Think of cracks forming on top of our baking baguette mountain.
Okay, the hard shell breaks.
Yes, and once those cracks opened up, water could get in. Water, plus the sheer force of gravity on that steep slope, started aggressively eroding the softer sandstone beneath the broken cap.
Ah, so it eroded from within the mountain.
Precisely. The erosion carved out the valley inside the mountain structure. That's the Machtesh. The cracked hard cap allowed the softer inside to be scooped out, essentially.
That's a fantastic explanation. But all that rock, the sandstone that was scooped out, where did it end up? The recordings mentioned it didn't just vanish.
No. Absolutely not. All that eroded material, sand, rocks, debris, what geologists call conglomerate, was washed down that steep slope into the Arava Valley. And it filled that deep rift valley up. We're talking an incredible depth, maybe 6 or 7 kilometers of accumulated sediment.
6 or 7 kilometers deep? That's unbelievable. How do we know that?
Well, remember that limestone layer that originally capped the whole region? Drilling and geological surveys in the Arava Valley have actually found that same limestone layer buried way down under all that accumulated conglomerate.
So the missing material from Ramon is found buried deep next door. The evidence fits.
Exactly. It's like finding the matching pieces. The Arava Valley was the basin that caught everything eroded out of Machtesh Ramon.
Mind-boggling scale. Is this erosion still happening? Is the Machtesh still changing?
Oh, definitely. It's a continuous process, though obviously much slower now than in its peak formation period.
And the recordings mention visible proof. Something about the hotel.
Yeah, apparently there's a noticeable crack in one of the support columns at the Bereshit Hotel. It's a subtle sign that the ground is still shifting, that erosional forces are still subtly at work, even affecting modern structures.
A crack in a hotel column.
Yeah.
That really brings geological time into the present, doesn't it?
It does. And you also have the flash floods.
Right, the desert floods.
Maybe 2 or 3 times a year, you get these massive, sudden floods rushing through the landscape. They carry significant amounts of sediment and debris out of the crater, continuing that transport process towards the Arava Valley.
So still actively reshaping things. One other point from the recordings, why aren't there huge piles of limestone boulders at the bottom if the cap broke off?
Good question. You do find some larger blocks, sort of mini boulders, but the thing is, even that hard limestone isn't immune to weathering over long periods.
It breaks down too.
Yeah, the constant exposure, sun, wind, temperature changes, the occasional water, it gradually breaks those bigger chunks down into smaller pieces. Think of it like giant Lego pieces slowly crumbling over millennia.
Persistent weathering. Okay, so despite this harsh eroding environment, the recordings emphasize life within the Machtesh. How is that possible?
Well, the key is water. There's a natural spring called Negev Midbar, sometimes referred to by its biblical name, Negev Middle.
A spring right in the desert.
Exactly. It provides a reliable water source, which is incredibly rare here. And around it, you see patches of green tamarisk trees, broom bushes, reeds. It's a little oasis.
Where does the spring water come from? It doesn't rain much there.
It's fed by underground aquifers, layers of rock that hold water. These get recharged during those big flash floods we mentioned. The water soaks into the ground and feeds the spring system.
Ah, so the floods are destructive, but also replenish the life source.
Precisely. And an interesting side effect, as the spring water evaporates in the dry air, it leaves behind visible salt deposits on the ground nearby.
And this water source wasn't just important for plants, right? The Nabataeans knew about it.
Absolutely. The Nabataeans, those ancient traders famous for Petra and their camel caravans, they clearly recognized the value of this spring. They set up a campground right near it. It was a vital stopping point on their trade routes through the harsh Negev. Water and a somewhat sheltered path through the crater walls made it strategic.
Wow. People using this landscape thousands of years ago. Let's jump forward to more recent inhabitants, the ibex. They sound like a real conservation success.
They really are. The Nubian ibex is native to this whole region, Jordan, Israel, Sinai. It's actually the symbol of the Israeli Nature and Parks Authority.
But endangered elsewhere.
Sadly, yes, globally they are considered endangered, but Israel has put a lot of effort into conservation, and it's paid off. There's a healthy, thriving population here in Ramon, also near Sleeboker in Gedi by the Dead Sea. Hundreds of them.
That's great to hear. How do they live? What's their social life like?
It's quite interesting. The females and the young ones, the kids, they usually stick together in herds.
Okay.
But the adult males, they tend to be solitary for most of the year, and they are impressive animals, long beards, these huge backward curving horns.
And they fight.
Oh, yes. During the summer, sort of July to September, the males have these intense dominance battles. They clash horns, fight for status.
And the winner?
The winner basically gets breeding rights with all the females in his territory, which can span several kilometers.
Winner takes all. How do they even define territory?
They mark it using pheromones in their urine and feces. It's a chemical boundary marker. And researchers are actually studying them closely here. Some have GPS tags tracking their movements, diet.
So we're learning a lot about them.
We are, and it's a stark contrast, unfortunately, to populations in Jordan and Sinai where hunting and maybe weaker environmental laws have led to declines. Ramon is a crucial refuge.
A safe haven. Okay, moving from living animals back to the deep past again. The recordings mentioned Ammonite fossils. Incredible. Where do you find those?
Yeah, there's a specific area, a well-known fossil wall, actually. It's on the outer side of the Machtesh, down in the lower sections.
Ammonites, those spiral shells you see in museums. What exactly were they?
They were ancient marine creatures, cephalopods, so related to modern octopus, squid, and especially the nautilus.
Ah.
They lived during the Mesozoic era, first appearing maybe 400 million years ago, long before the dinosaurs really took over on land. And they were incredibly successful, hugely diverse, over 30,000 species known, all sorts of shapes and sizes.
30,000 species. So the ancient seas must have been full of them. How did they live?
They had these chambered shells, which were amazing adaptations. They could adjust the gas and fluid levels in the chambers.
Like ballast tanks.
Exactly, like tiny submarines, controlling their buoyancy to move up and down in the water column. They also had a siphon they could squirt water out of for propulsion and probably to help catch food.
Clever design. What happened to them? Dinosaurs went extinct, did they too?
Yes, the timing matches. They largely disappeared around 66 million years ago, coinciding with that major extinction event, likely triggered by the asteroid impact.
Why were they hit so hard?
The thinking is that many Ammonite species laid their eggs in shallower coastal waters. Those shallow marine ecosystems were devastated by the impact's effects, tsunamis, changes in sea level and temperature, so their reproductive cycle was fatally disrupted.
Reliant on vulnerable habitats. So the fossils we see, they aren't the actual shell, are they?
Not usually the original shell material itself. What we see are primarily impressions or molds in the limestone rock.
Okay, explain that.
So this limestone layer formed around 100 million years ago. When ammonites died back then, their calcium carbonate shell sank into the soft, muddy sediment on the ocean floor.
Right.
Over time, the organic parts of the shell dissolved away, but they left behind a perfect mold of their shape in the surrounding mud. Then, under pressure, that mud hardened into limestone, preserving the impression.
It's like leaving a footprint in wet cement that then hardens.
Exactly like that, a fossil footprint of the shell.
And how did these fossils, formed deep underwater, get exposed on the side of a crater wall in the desert?
Again, it comes back to those tectonic forces. Around 60 million years ago, the folding and uplift we talked about tilted these rock layers.
Okay.
Then, millions of years of erosion stripped away the overlying rock, eventually exposing this specific ammonite-rich limestone layer right there on the crater's edge.
So geology first buried them, then uncovered them. Amazing. And these are protected, right? You can't just pick them up.
Absolutely protected. Israeli law is very strict. You can look, photograph, but definitely not remove or damage the fossils. They're part of the natural heritage.
Good. Now, the recordings also made a point about finding them on one wall more than the other. Why is that?
Ah, right. That's about the different geological layers exposed. The other wall of the crater, the opposite side, is mostly made of a younger rock called chalk.
Younger.
Yes, formed maybe 25 million years ago, so much later than the ammonite limestone. It was deposited after the main folding event that brought the ammonite layer closer to the surface on the first side.
So the ammonites are probably under the chalk on that other side.
Exactly. To find ammonites on that chalky side, you'd have to somehow dig down through millions of years of younger chalk deposits to reach the older limestone layer where they're preserved. The erosion just hasn't cut that deep on that side yet, or exposed the same strata.
Different parts of the crater show different pages of the Earth's history book. Incredible.
Yeah.
And there's a living relative still around.
Yes, the nautilus. It's often called a living fossil. It's a cousin of the ammonites and still lives today, though mainly in the deep ocean, Pacific, and Atlantic. So a little piece of that ancient lineage survives.
Wow, what a connection across time. Well, this deep dive has really been something. A journey through, what, hundreds of millions of years.
It really has. We've touched on these immense geological forces, ancient rivers, oceans, mountains rising, the Rift Valley tearing things apart, relentless erosion sculpting it all.
And then the life that clings on or leaves its mark. The ibex thriving against the odds, the echoes of ammonites in the rock.
It puts things in perspective, doesn't it? The sheer scale of time, the constant change.
It absolutely does. And it makes you wonder, considering erosion is still happening, the land is still subtly shifting. What will Machtesh Ramon look like in another million years? Or 10 million? What future transformations are in store?
That's a great question. It's not a static museum piece. It's very much a dynamic landscape, a story still being written in the rocks.
The story's still unfolding. Well, we hope this deep dive has sparked some curiosity for our listeners. There's so much more to Machtesh Ramon. The minerals, the Bedouin history.
Absolutely. It's a place with many layers, both geological and cultural. Maybe it inspires someone to go and see this incredible wonder for themselves.
Perhaps so. Thanks for joining us on the deep dive.